Okay, so Bhargavi, yes, should I give how much time? We have half an hour. Okay, let me see. You'll acquire a lot of questions there. Detecting stack overruns without using debugger. Okay, so I guess you would have watched there are videos on memory usage and so on. So I'll just recap from this. So the typical layout of memory, let's say there is heap, there is stack, and then some area, and then there's globals, right? So this is the base of the stack, and stack pointer will move. So when it oversteps onto the globals, let's say this is, it is basically moving here, you have a danger. So this is overflow. So this is a limit. So this is the base, this is the limit of the stack. If your stack pointer crosses the limit, then you have stepped on to, so you're basically having a stack overflow. So one way to track is compare stack pointer with the limit. So how do you, basically, when do you do that? You can do it at function entry points, where you think there is a lot of nesting of function calls happen. You can also do that in programmatically by, so how do you get a stack pointer in C code? You can take the address of the local variable, the first local variable, which is not, or a parameter which is not in a register, right? And then basically with respect to that, you can compare that with the stack limit if that information is accessible, and you can say whether you have overflowed or not. So this is one simple technique, but yeah, you have to instrument the code for that. The next thing that you would do is basically, so you can also run a separate background process which tracks the stack pointer throughout and periodically sampling the stack pointer. But then that is a very intrusive thing. That it may be not intrusive for the functionality, but performance-wise it may be intrusive. The other thing that one does is you have this heap, you have the stack, and then you have what is called a GodZone. So basically you reserve that. And then so you separate the globals here. Now you fill, when the stack is, so this is the base, you fill the stack, debuggers typically do that. You fill the stack with a certain pattern. So the GodZone pattern. So there are two patterns, stack pattern, say stack pre-fill pattern, and then GodZone pre-fill pattern. Say you fill, typically I've seen ARM compilers do CD. And when the stack is unallocated initially, it fills with this. Now, without the GodZone, you can still say, given a stack pointer, okay, you know how much, by scanning this memory, you can say how much stack you have configured, here is the limit. And so if the stack pointer never grew, so up to the limit, these things are untouched, so it will be having this pattern. So by reverse scanning from the limit and looking for this pre-fill pattern, you will know how much stack size you have used in this execution run. So you can use this to size the stack properly. So you avoid stack overflow. So you look for this pre-fill pattern after running from the limit to the current stack pointer or entire stack zone, and see how many CDs you see, that many bytes are actually available, have not been used. So your stack can be safe, or you can reduce the limit, stack limit also, stack size also. So that is as far as the stack pre-fill pattern is. Now you can also put a pattern in the GodZone. You can put something like A5, etc. Something which is unique pattern, and then see if those unique patterns are intact. if they are not intact, that means overflow has happened. So the stack pre-fill pattern is used for underflows, basically to see if the size limit that you have provided is good enough. And the GodZone is for overflow detection. Basically, you can scan the GodZone and see for the pattern signature. If the signature has been overwritten, then the stack has overflowed into the GodZone. This is basically how compilers, debuggers can provide you stack information, but you can do that yourself without the debugger. Of course, there are other techniques. For example, you place the stack limit, okay, at the edge of protected memory. What happened, or non-existing memory, right? So when you do that, when there is a overflow, then you will have a exception triggered, hardware exception triggered, right? Memory exception will happen. So you can have a exception handler will be called, so you can know that stack overflow happened. So basically, instead of pre-fill pattern, but of course, provided you can place it like this, you place it at the, you won't have so much physical memory. So where the physical memory ends, you just align the stack to that. Since stack overflow means it will basically create an exception, non-existing memory being accessed. You can have an exception handler to tell you that stack overflow has happened. So this is another technique. Okay.
Thank you.
Okay, so now I'll come to Bhushan's question. Is again a generic question. Design a smart thermostat. How to approach a design problem? Is there a general pattern that needs to be followed? Requirements gathering, hardware, software design, state machine. Yeah, of course, those are all the things. So basically, what is that purpose of this kind of opens one line design questions, right? So it's an opportunity provided by the interviewer to demonstrate certain design skills, right? Not only technical skills, so the skills, it could be, design skills, it could be requirements gathering skills, it could be other soft skills, basically communication skills. So it's an opportunity, irrespective of what the problem statement is. And then it also means certain degree of awareness of product awareness, right? So that is what the designer is, the interviewer is looking for in such questions. He's not asking you to implement it anyway. So it's about how you think. So the problem statement, something like smart thermostat, right? Now, I'm sure if not, you have not designed it before, at least you would have used one. So as a user, what can you say about requirements, especially the functionality? Non-functional requirements may not be possible. But do you know what this is supposed to do, a thermostat? The main functionality is to control temperature. And then there may be other smart functionality. So smart functionality means how adaptive it is, or can it learn usage patterns, etc. So as a user, you should be able to place those. Instead of freezing there, you think of as a user, if you have seen one, or if you have read about one, or if you have used one, you would be able to describe this. Then you can elaborate on this requirement. Then there could be also business objectives. Are you able to think beyond technical? Are you able to think business objectives? For example, a thermostat can be just a device that is sold on its own, or it could be a service as a service, right? For example, your utility bills can be enabled. So you basically, the value proposition is you reduce the energy bills by using this device. So the smart thermostat's job is not just to do what it is told, but the business objective is to produce lower energy bills, and therefore a percentage of that is the revenue for the device vendor. So are you able to see beyond the hardware piece or the product? Are you able to see what business it enables? That's a good desirable attribute to think of. Of course, when you think in so many dimensions, you may lose track of essential. So you should always think about what is the minimum viable product. Don't, are you having a tendency to complicate? So this is what the interviewer will be looking for. Are you able to simplify? Are you actually dealing with ambiguity? So these are the things that you will be signaling through your responses, right? So you should be aware of these kind of angles that you would be expected to approach. Now we talked about smart, so then you can derive some, is it a connected product or a standalone? Okay, so how does it interface to a gateway or a cloud service, cloud database, or whatever? So you can, now this is where your background helps, right? Now in the interview, you might have experience working only on an embedded device. You have no idea about the cloud. So it's an opportunity for you to direct, to your strengths. So don't get into areas which you are not strong in, right? It may actually, you may be ending up in trouble. So you, like in any interview, you bring the conversation to your strength. So if you are familiar with a gateway product, you can talk more about the communication angles to that. And if you have done some cloud database or provisioning or those kind of things, you can talk about. So while the connected product, smart product may have all of these, where do you emphasize? It's up to your strength. Of course, you cannot completely be ignorant of the other parts, but you speak more on what your strength area is, right? And of course, the design skills will come after all this. So basically, where do you come from? Are you a hardware engineer or a software or firmware engineer or a database designer, etc.? So you would basically elaborate based on that. And you also mentioned hardware software partitioning. Now, when you talk about this, okay, or for that matter, any design, are you able to give rationale for this, why you want partitioning in this way? First, are you thinking about partitioning and rationale, for example, performance, battery life, or cost, etc. What do you do in hardware? So justifications or rationale you should have to articulate. Then, of course, you would talk about non-functional requirements, modularity, for modularity and other things. So maintainability, configurability, deployability, and things like that. Are you able to talk about non-functional requirements? And therefore, a choice of a platform. So this is important, but this is not primary, but it is basically, are you aware of any platform? Okay, so you say, I have used this platform. It's good because it provides a hardware accelerator for certain computations, whatever. So basically, you are bringing your past experience in making these choices. And in the process, you are communicating your knowledge and awareness of what you have already worked with. So this new problem statement is just a context to elaborate on what you already know, provided you can link it up for relevance. Then comes how do you communicate, right? So we talked about requirements. So asking or confirming. It's better to say, okay, this is what I think. This is the assumptions I'm making. So this brings you a clarity of what bounds you are putting on the problem statement. Are you able to communicate that? And then, of course, design wise, block diagrams or any other diagrams, context diagrams, tech stack. Are you able to communicate what is the tech stack you are using and how they are providing different services? And most importantly, design alternatives, if you can think of, and then the rationale for choosing one choice. So basically, you are given an opportunity to free opportunity to exhibit all these skills. Your awareness of a product, some business angle, some deployment angle, that is, and then in basically nailing the requirements, and then in simplifying the problem, because you're now doing a toy problem, to what is essential functionality and what is essential non-functional requirements are. And then are you thinking of leveraging your past experience, and are you bringing some value to the table because of your past experience with a platform or a tool or something like that? And then communication with block diagrams, text. These are the tools that engineers communicate. So are you familiar with those things? So you may be asked to draw a state machine. So maybe not asked, but if you do these things, then you're talking engineering language. So that is basically what the approach I would think of for such questions. Yeah, Bhushan, you have any more comments to make on that? Okay, so.
Hey Raghu, I have a question.
Yeah.
So in the specific design, right? So the specific smart thermostat. So I have seen like few blogs where they use like ARM-based microcontrollers, but to be more specific, like in your experience and dealing with the product, like which type of tech stack or microcontrollers have you seen more commonly used, or how does it typically?
Yeah, definitely any connected product. If you're talking about smart, you can think of it in three ways. Basically, the core functionality of sensing and any control interface. The microcontroller platform should support that, right? The sensing of a thermostat is important, and any control interface for controlling the HVAC system. So those basic peripheral interfaces the platform should support. Then comes the software stack in terms of connectivity. So are you talking about Wi-Fi, or are you talking about Bluetooth or any other connectivity? So the platform should support, as well as the software platform should provide you the basic connection stack, connectivity stack. Then, yeah, of course, it's battery powered or it is powered, line powered is important in the choice. Once you have those basics out of the way, then comes the tech stack, mostly to do with device management, software updates. How do you do? Does the platform provide those things? Because basically, once you deploy, again, these are consumer products. So you can think of a thermostat traditionally were installed by industrial automation guys, basically the HVAC guys. So the professional installation is done. Now, these smart things may also be done by professional installers, especially if the business model is based on energy saving. But it could also be consumer self-installed device. So the configuration, how does it actually start? You just plug it in, power it on, and then you expect it to work. There are a lot of behind the scene things that go on in basically device onboarding, authenticating the device. You may be asked to do a pairing of some sort, identity management, device identity management, and all that. So you have to know whether your platform can support those things like software update. So is there sufficient flash memory to have 2 or more images of the firmware to do a over-the-air update, so you can actually do. So again, those are the choices that you would make from a deployment perspective. So does it answer your question?
Yeah, so one other portion of it was, is there like a general guideline as I mean, there we can't exactly have like one specific of MCU or this thing, but are there like a class or family of microcontrollers that could fit into these different types of applications, and how can we like probably identify them? Because for some applications we might know, some applications we might not know if one might fit in or not. So is there like any
Yeah,
guideline?
it'll depend on obviously the kind of product that you're talking about, right? So if you're talking about a consumer or industrial product. Now, if it's a VR headset, then you need high performance platforms, like the one from Qualcomm. So basically, to know that if you know this question is coming because you're attending an interview with a certain group, you can do some research and find out what they already use if it is available. Otherwise, it's very, generic platforms are good enough to start with, and you can state so. I'm not familiar with the best platform for this kind of product, but assume I have worked with such and such low power product, or a such and such low cost product, or such and such high performance product, and extrapolate. So if you work with the TI product, which basically does what the Qualcomm product does, maybe more or less, it's fine. You can bring that on. So it's not necessary, because if you know, go and do the preparation, then obviously you will know much more. If not, if you're suddenly blindfolded and asked this question, you have to leverage what you already know, that, and you can make a reasonable assumption. So obviously you won't choose a multi-core processor platform for a thermostat. Those kind of common sense filtering you can do, right? Industrial, typical, as an engineer, embedded engineer, you should know which platforms are popular, which microcontrollers are popular for which applications. It's a professional, upkeep that you have to do, scanning magazines or whatever, to know which are the application. You can read the processor application notes. You would know. I mean, the semiconductor vendors publish all kind of information about the various applications. Periodically, you have to equip yourself with, okay, earlier it was MSP 430. What is the equivalent of MSP 430 now? Popular in the ARM family. Do people use it? The ST micro platform has an equivalent for that. So I think that is part of a professional upkeep, knowing the generic application space for which what platforms are used. Automotive specific grade components may be different. So if you're talking to an automotive company for an interview, you're expected to know the typical, some groundwork you may have to know if you have not already done.
Okay, makes sense. Yeah, thank you.
There's no one shoe fits all kind. Okay. So
yeah, definitely. But
I would strongly advise not prepare for a target interview. If you are generally keeping yourself informed, reading online magazines or otherwise, you will be good. And you can be saying that this is all I know, but I will use this to explore this problem. Okay. So as that itself is not important. You're not actually building the product. You're only doing an interview. As long as you're communicating, you're thinking, clarity, etc. are established, and your background, how you leverage is established, you're good.
Okay. Sure.
Okay, I'll move on to the next question. Okay, that brings Subhash's question on over there updates. What are the techniques and risks? So basically, I will divide it into two parts. What are the risks and software updates in general? And then we'll talk about additional risks that happen, in over the air kind of updates, right? So basically, software updates, how are you doing it? Is it a standalone device? Okay, a standalone device or a network of devices? We'll talk about it a little later. Basically, when you're doing software updates, you insert a media or through a network, you are delivering the image, new firmware image. What can go wrong? So basically, the trust of the device in its environment, right? Who can update? So if it is a remote device, for example, you need to know how to initiate the software update, right? A technician goes and then there may be a secret UI, unpublished UI, some combination of buttons which will go into update mode, and then it may be protected by a pin, and then you may initiate the media related thing. Then of course the trust of the so basically the identity of the person updating it. When you're talking about over the air, it becomes a little different. But I'm talking about physical updates, right? The trust of the image software itself, right? So you need signatures for that image. So there must be a way of verifying the signature.